A warm good morning to one and all present here. I am going to present a small research work on performance assessment of conceptual bifacial solar PV system for different albedo conditions. My name is Srinath. I am presenting this work on the behalf of Dr. K. Sudhagar and you and Ahmad Fitri Yusuf. Coming to the introduction, I would like to start with the power flow diagram of solar PV system. As you know, solar PV system consists of PV modules, and the energy produced from PV modules will be converted to AC from using inverter, and then it will be used for the domestic load, and a part of it will be, and the remaining part will be fed to the grid, to the utility power line. So coming to the bifacial PV modules, so there is a need to improve the solar PV energy output. So with that intention, bifacial PV modules have been fabricated, in which the power generation is also possible from the energy from the solar radiation striking on the back side of the solar PV module. As seen in this figure, the sunlight that is coming from the top side as well as back side is contributing to the energy generation. So coming to the problem identification, there is always a need to maximize the solar PV energy generation, because solar PV system requires a lot of land. So by increasing the efficiency, this land requirement can be reduced. So one way of reducing it is to use bifacial solar PV modules, because it can use energy from the back side as well as the front side of the PV modules. But at the same time, the amount of solar radiation that strike on the backside is influenced by one factor called ground albedo. So this varies with one surface to the another surface. So here in this work, the performance of bifacial solar PV system for different albedo conditions in an education institution is studied. And coming to the objectives, first objective is to evaluate the energy performance of bifacial solar PV system for different albedo conditions, and which are located in education institution. And in this case, I have chosen University Malaysia Pahang Pekan campus for the study. Also, the second objective is to find a suitable area for bifacial solar PV system. Coming to the methodology, this is the map showing the 4 sites selected in the University Malaysia Pahang Pekan campus. All sites are having equal area, and hence it can accommodate 100 kilowatt PV system, but the albedo angles are different. Regarding it, in this slide I have framed a table. So site 1, it is using bifacial solar PV system, and the ground surface area is asphalt, which means the area is a car park area, and then the corresponding albedo factor is 0.15, and this value is obtained from standard table from the online source, from online PV software. And coming to the another site 2, we have grass, and site 3 concrete, which is having a bit more albedo factor, and then site 4 aluminum, which is having a highest albedo factor of 0.85, because the aluminum will reflect more solar radiation, because that is smooth surface. And at the same time, we are comparing these performance with one base case where we will be using a monofacial solar PV system. And for that, the types of site, ground surface, albedo factor, everything are immaterial. So coming to the software used, PVSyst is one of the industrially used as well as researchers used software for PV simulation. And in this software I have utilized the um, model for bifacial PV, and that is called as ultimated shuts. And for this, within this model, there are few assumptions like the single orientation of bifacial PV array is considered, equal distance is considered, row distance is considered. So there are some assumptions involved. At the same time, from the previous studies, it is came to know that the results provided by this software for the bifacial solar PV performance is almost equal with the actual performance. It is closely matching with the actual performance. So we can give parameters like albedo value, shading factor, mismatch losses, etc. to the software. At the same time, the other PV design factors like tilt and azimuth angle, shed width, height above the ground can also be provided. Now we'll come into the simulation procedure. At first, the geographical location of the PV system is provided, and based on this, the corresponding meteorological data can be retrieved from the software, and after that, the main input parameters is provided, and these parameters will be discussed further. And based on this given input parameters, the system will propose a basic configuration, and we can check that configuration, and if it is okay, we can manually check it, and if we are also okay, then we can proceed for the further step wherein some reasonable default values are pre-filled by the software for some other negligible or like unimportant kind of parameters like near shading or like the ohmic losses, everything which can be assumed. And after this, we will get the results. Basically, performance ratio, energy yield. These parameters are of the interest of the present study. So coming to the solar PV system design, we have chosen a 520 watt efficiency solar PV module. Both it are the same for bifacial as well as for monofacial. And for a 100 kilowatt system, 18 modules in series is needed, and total 198 number of PV modules are required. And the tilt angle, the angle at which the PV module is oriented is 10 degrees. It is because of the latitude of the Malaysia, which is 3 to 4 degrees. At the same time, a little bit higher angle is given so as to facilitate the self cleaning during rain. And azimuth angle is kept as 180 degree. That is because uh, in northern hemisphere, the solar PV system has to face southern side for maximum energy production. Also, a 100 kilowatt inverter, single inverter is chosen for the proposed solar PV system. And coming to the climatic and radiation data which is retrieved from the solar PV software, it can be seen that second column which gives the global horizontal irradiation. It seems that April is having the maximum irradiation, then followed by uh, June or something. Then the minimum is coming on December. Similarly, for ambient temperature, the highest value is observed uh, in June, and wind speed highest value is in January. So mainly the global horizontal radiation and the ambient temperature will affect the uh, energy production. So coming to the main parameters considered, we are interested in three parameters basically. One is the annual energy generation, then specific yield, which is the ratio of the energy generated to the installed capacity. Then performance ratio is an important factor used to measure the performance of solar PV system irrespective of their location, and also it will give us an idea about the losses in the solar PV system. If PR value is more, it means that the plant is performing in a better way. So coming to the results as well as discussion. For the first set of monofacial PV module, it is seen that the performance ratio is around 85, and the total annual energy generated is 159 megawatt hour, and the highest energy generation is obtained in April and the lowest one is in November. Okay, then coming to this is for the monofacial PV system. So where the albedo factor is not important. So coming to the bifacial PV, at the minimum in the present study, albedo factor 0.15, that is asphalt surface. We got a little bit higher energy generation, 169. Previously it was 159. This is 164. 5.44 megawatt hour energy increase in an annual scale. So this is due to the use of bifacial solar PV system, which can use solar irradiation from the falling on the backside of solar PV module. Coming to the performance of bifacial PV at 0.15 albedo factor, it is seen that the performance ratio reached 90%. Previously it was 85 to 90 in the previous two cases. In this cases it touched 90% PR, which is itself is a appreciable value when compared to the other industry standard, which is around 80 only. So using bifacial PV at 25 degree 0.25 albedo, we are able to get 90% performance ratio, which is 5% more than the base case value. However, the remaining variation of the energy generation as well as the PR value, the variation remains almost same. And coming to bifacial PV module at 0.35 albedo factor, we can see that the annual energy generation still increased to 172 megawatt hour, and which is 7.5% more than the first case value, and it's a remarkable increase. So especially this increase will play a major role in the levelized cost of electricity as well as the economic viability of the project, because as the energy generation increases, it will affect the payback period, it will reduces the payback period as well as the net present value, etc. So coming to the last case, where we are having the highest value of albedo, the highest value of energy generation is observed, that is 175.78 megawatt hour, and average PR of 94 percentage or 0.94 is observed. This can be attributed to two things. The first is the use of bifacial solar PV system, and second thing is the highly reflective foreground surface, which calls for 0.85 maximum albedo value. However, the variation of the PR is almost constant. It varies between, I think, from 0.92 to 0.95, and the variation in energy generation is almost is almost in line with the previous graph. So here we are going to compare the performance, and for the first case it is seen that the energy generation, which is in blue color, and the green color PR is on the minimum, and as the albedo factor is increasing, the energy generation as well as PR is has increased and reached maximum for case 5 value. So a linear increase is seen in the energy generation with respect to the albedo factor. However, the monthly variation PR is minimum, and the peak value of energy generation is observed from the previous graph in April month. So based on these studies, the following conclusions are drawn. First of all, the energy generation of PV system and the performance ratio for 5 cases has been studied here is estimated. It is found that the case 5, which uses aluminum surface as the foreground surface of bifacial solar PV system, has the best energy performance. However, monofacial solar PV system has the lowest energy output. It is also seen that the energy generation varied as the albedo surface of the surface increased from 0.15, 0.25 in that sequence. In the same linear sequence, solar PV performance also increased. And coming to the next point, the suitable location is found to be site 4, because that is having the maximum energy generation due to bifacial solar PV and high value of ground reflectance. And the significance of the study is that this use of bifacial solar PV system is expected to increase in the coming years. So definitely this study will be beneficial to energy professionals, project developers and investors, because the quantity of studies in using solar PV, bifacial solar PV is less. And one of the good future work of the study is to check the effectiveness of highly reflective paints on albedo and simultaneously on the performance of solar PV system. So I would like to acknowledge UMP for DRS as well as for the PGRS grant. And these are the main references from PVSyst software, then from NIT 3EEE and from bifacial PV system, and there is from bifacial papers are given. Thank you. Thank you, terima kasih. I hope this section find useful to all of you. If there is some queries or suggestions, please let me know. Thank you.